Okay, in the same material analysis, if you remember previously, we have just determined different materials in brickwork, okay, and then in PCC, also in RCC, and then we have, if you remember, calculated different materials used for the plaster and something stretch. Okay, now in the same video, we will carry the same topic and we will be just analyzing the materials used in or maybe for whitewash, okay? And for the same whitewash, or you can say the materials to calculate, and those materials can be actually maybe lime, maybe glue, and then color can be added sometime, okay? So we will be just determining the lime, then the glue, and then of course, okay, instead of glue, rice can also be added, okay, for the bonding purposes. So glue that is just normally used, however, rice can also be added. And the color is just a good thing you can say, okay, just maybe for the beauty. Okay, so let's move ahead and let's see. We may have some points, okay, just to you guys have to remember these points in order to determine the quantities of different materials for the whitewash, okay? And the points are, you can say 2 kgs of lime must be used, okay? You can say 2 kgs of lime for 10 square meter surface, okay? And this is actually unslaked lime, okay? This should be required with 0.06 kg glue, and this you can say 10 or maybe 10 square meter, which is required in 2 kg lime, that is just for the single coat, okay? This video can be different. I mean, the 2 kgs per 10 square meter, that can be different for a two coat whitewashing. And that is actually 2.8 kg, okay? So you have to just buy, or maybe it is required to have 2.8 kg per 10 square meter, okay? Of white fat lime. Okay, so the glue is actually the same for the two coats, okay, or maybe for the double coat whitewashing. And then for three coats, it is just completely different. You can see the lime should be 3.5 kgs. And as you can see, the unit rate, that is just the same. I mean, the unit of work, which is 10 square meter. And then the glue, look at that. It is actually twice, which is maybe 0.12 kg, okay? And this is for the three coats. And the color, however, the color can be depends on the choice, okay, of the client, which means the color can be lump sum, okay? So we can add it lump sum. And by lump sum, I mean that it can be any video, maybe anything like can be even maybe 100 grams, can be 200 grams, can be anything, okay? So it depends on the choice. Okay, and I think to understand these things better, we should have an example, okay? Because example can be a better way to understand the problem. So let's have an example, and let's say if we have a wall, we will just consider a wall, and the wall, let's say it is just 15 times 5 meters, okay? 15 is actually the length, and 5 is actually the height. Now, you don't actually need to calculate, okay, just maybe a single wall, then another wall, then another wall, okay, adding them, it will take much time, okay? If you remember previously, okay, in maybe in the last video or maybe in the last lecture, we have already calculated these things, okay, using Excel sheet. So you have to do all those things in the same Excel sheet, and then the analysis, for the analysis, the quantity of the work should be taken, okay? This time I'm assuming a wall only, okay? So we are just required to determine different materials for the whitewash. And as you can see, we are informed to have three coats. We're here, you can see it. So the coats are three. And this is actually just a fresh plaster surface, okay, or fresh plastered wall. All right. In the solution, I should have the whitewash area, which should be actually 15 times 5. It is just simple, okay? It is just a rectangle. That's why we have just learned about areas, okay, in the very first lecture. And 15 times 5, that is actually 75 square meter. Okay, it is just clear. Now we will just calculate the quantity of the lime, which means unselect line. Okay, unselect line is just you can say required. So the lime for the lime calculation, you should remember those points. Here, as you can see, we have three cores. It means we'll be just using the point number 3. Okay, it means 3.5 kg per 10 square meter. Okay, we will take the 3.5 kg, and that is actually we will divide that by 10 because the unit work is just 10. Okay, and our quantity, or you can say the surface, that is just more than 10. Okay, so it means 3.5 divided by 10, and we will multiply the total whitewashing area. Okay, that is 75. Just it is just simple math. Okay, you have to just multiply 75 times 3.5 and then divide it by 10. So you must have 26 kgs lime. It's a pretty good. Okay, very simple. So for the same wall, 26 kg or maybe more, like, okay, because we have 0.25, it means if you take it like maybe approximate, so you have to just buy 27 kg of the lime, okay? Next, we will be just determining the glue for the same work, okay? And now glue, for the glue, we have to remember the same point, okay? Which is actually 0.12 kg. Again, 0.12 kg divided by 10, because 0.12 kg that is just for the 10 square meter work, okay? And however, we will multiply that with 75 because that is the total whitewashing area. And this should be actually zero point 0.9, which is approximately taken is 1 kg. So for the same work, as you can see, we have 27 kg is the lime and 1 kg is the glue. Pretty cool, okay? It is very easy. Is there any question?
No, sir.
Okay, because it's very easy and you guys, I think, are already familiar with these things. Next, I'm gonna have some work with the floors, okay? You can say farsh in Urdu. Now, floors can be of different types. There can be floors of tiles, okay? There can be stone chips in the floor. Okay, the floor can be of PCC one. The floor can even be RCC. Okay, just you can say for the maybe for the factories. Okay, because there we may have heavy load, so RCC floors are constructed. Okay, and so on. You can say ETC. Okay, so floor can be of different types. And because of that, the analysis can be different, okay? However, we will have just an example to clear the idea. We will not spend much time on each floor type, okay? So let's move ahead. And let's say if we have the same, very simple, okay? Let's say this is the section of a floor whose area is just 30 square meter. Okay, this is the total area. You can consider a room maybe, which is actually like AB. Okay, now A times B, that is actually the same thing as 30 square meter. So the section is given, and we are asked to calculate materials for the given floor section. Now, subbase, you can see subbase is actually brick ballast. And then we have base is concrete, which is actually 136. And the topping, that is actually cement and then stone chips, okay? And that is 1:3. Okay, we have already covered the concrete, which is 136. However, we have not yet covered about the stone chips. Okay, so topping, that is very important, in the brick pillars. Let's just move ahead toward the solution. And in the solution, as you can see, the brick ballast can be which is in the subbase, and that can be actually in terms of volume. Okay, and if you remember, we have already covered volumes in the second lecture. Okay, this is the reason I have covered those things, area and volume. Now, what should be the volume? The cross-sectional area, or maybe the top area times the thickness. Area is given, okay? The total area, or you can say the total floor area. That is just 30 square meter. Okay, and then we will multiply the same area with the thickness which is known, and it is 12 centimeters. Okay, so this is the quantity of brick ballast. As you can see, we have the total floor area. Okay, that is just 30 square meter, you can say, and we will multiply that with the thickness which is 12 centimeter, or you can say 0.12 meters, because if you see 1 meter, that is just the same thing is 100 centimeters. Okay, so in order to convert centimeters into meters, you have to divide that by, you can say, 100 centimeters. Okay, so we have 12 centimeters, it means 12 by 100, which is the same thing as 0.12. Okay, that's why we have 30 times 0.12. Okay, multiply these two, we should have the break ballast in the subbase maybe, and that is actually 3.6 cubic meter. Okay, which is a huge video, cubic meter, because the floor is very wide. It is 30 square meter, maybe like a hall. Okay, it is a huge hall, you can say. Now you may have question about the compaction factor. Like maybe if we have thickness, like let's say if this is floor and if we have 10 centimeter thickness, now after compaction, the thickness may decrease to 8 centimeters, maybe 5 centimeters. So why I'm not taking that? Because we don't compact brick ballast, okay? This is the reason I'm not including the compaction factor. Because if you compact brick balanced, they may become very small, okay, and weak. So this is the reason. As you can see, we have the subbase, and in the subbase, we have actually the concrete work, which is 136. Okay. Now 136, or maybe the concrete work should be actually 30, which is the total area of the floor, and again times 12 centimeter. Okay. This is concrete, very simple, or you can say 0.12 meters. Okay, multiply these two, we should have 3.6 cubic meter. Now, it is the same thing as the wet concrete. We have to multiply the wet concrete with 1.54 to convert this into dry, okay? And then from the dry volume, we can calculate cement, sand, and crust stone, right? It is the same thing as PCC work. So moving ahead, the material, it is the same formula, okay? Just discussed many times in the previous video, so we will not waste our time over here. Now the cement can be calculated. For the cement, the ratio of material can be taken, okay, which is actually 1, because we have ratio is 136, okay? In the same ratio, 1 represents the cement ratio, okay? So 1, and we will divide this by the sum up ratio. The sum up ratio means 1 plus 3 plus 6, and that should be actually 10. Okay, so 1 divided by 10 times the dry volume. Now the dry volume can be very interesting, but we have already just covered it. Okay, that's why I'm not gonna spend much time again. Okay, the dry volume is actually, you can say, the wet volume times a factor, and that factor is actually 1.54. So we may have the dry volume is 5.544, okay, cubic meters. Now, what's 1.54? We have already just covered that. Okay, I'm not gonna repeat that again because you guys are not asking me that. It means you are clear about this. Okay, so the quantity of cement can be 1/10 times the dry volume. It means the quantity of cement should be now 0.5544 cubic meters. Okay, now this is in cubic meters. You have to convert this into the bags. Okay, for that you should know the volume of one cement bag, which is actually, we're here in Pakistan, that is just 0.035 cubic meters. Very simple, okay? So divide that by 8, and it should be 15.8 bags. You can say 16 bags, okay, for the same floor. Now, the sand can be calculated from the quantity of cement. Now, the quantity of cement that is just 0.5544. Multiply that with the ratio of sand, which is actually 3, and that should be the same thing as 1.66. Now, the crust tone can be calculated. Okay, crust tone that is just known by the Bajri. okay, in many countries, maybe like Pakistan, Afghanistan, India, okay. So Bajri is just used for the crust stone or maybe for the coarse aggregates. Now the quantity of Bajri can be actually the quantity of cement, which is 0.5544, and we will multiply this with the ratio of the crust stone or Bajri, which is 6 in the ratio, okay. So it is actually the same thing as 3.326 cubic meter. This is it. Very easy. Okay. All right. Next, we have another problem, which is actually the topping. And this is very important in the same topic because we have already covered the sub-base base. Okay. Sub-base and base. That's why I just did it very fast. And however, I'll take some time with the topping. Okay. Topping that is just known by the top surface of the floor, you can say, okay, and that is just uh, constructed of the stone chips and cement mixture, okay, like in cement mortar what we have is actually the cement plus sand, and stone chips, or you can say it is just like a mosaic floor, okay, where we have cement and then stone chips, which are just 5 mm in size. Okay. So again, the topping stone chips, that is 1:3. It means one is just the cement and 3 times of stone chips is taken. Very simple. Okay. Now the total area that is just given. So the total wet volume can be calculated the same thing as the area times the thickness. Okay, area is known 30 and the thickness that is just 4 centimeters. Or you can say 0.04 meters. Now the volume is actually 1.2 cubic meters and we can calculate actually the materials. The same formula can be used. Ratio of material divided by sum of ratio times the dry volume. Now, in order to calculate the quantity of cement, it is the same thing like 1 over 4, because 1 is the ratio of material, 4 is the sum of ratio for the same topping, okay? And this is actually 1 plus 3. So we have actually the sum of ratio, and that is just 4. So 1 over 4 times the dry volume. And dry volume, it is just the same thing. Is we did it maybe in previous videos or in lectures. The topping actually is the same thing as cement mortar, okay? Because we have only two materials, the cement and the stone chips. Okay. If you have the bajri or cast stone, then you have to use 1.54 because that becomes then maybe concrete. Okay. This time it's like a mortar because we have only two ingredients. Okay. So the wet volume times 1.27. Now what's 1.27? We have already covered this. Okay. So the wet volume that is known 1.2 times the factor. So we have the dry volume equals 1.524 cubic meter. We will just bring this video over, okay? So we have the quantity of cement, which is actually 0.381 cubic meters, okay? Now divide this by the volume of one cement bag, so we can have the quantity of cement in cement, you can say in number of bags maybe, okay? All right, so now we have the cement bags, which is 10.88 bags for the same topping only. And next we have actually stone chips, which are, you can say, just small stones, okay? You may have seen these things on site, maybe in your home while constructing floors, okay? So the stone chips should be the quantity of the material divided by the sum of, I mean, the ratio of the material divided by the sum of ratio times the dry volume. However, we can also calculate this by the shortcut, which is the cement quantity that is just known. We have calculated that few seconds ago times the ratio of stone chips, which is actually just 3, you can see that. Okay. And this becomes actually now 1.143 cubic meters. It means for the same floor, which is 30 square meter, we have different materials. The brick ballast, we have actually the cement, which is 15.8 bags. We have actually the sand, and then we have the budgery. Very easy, okay? And then actually in the topping, we have cement and then, of course, stone chips. Is it clear? Is there any question? You guys can hear me, right?
ये स्टोन चिप्स जो होते हैं सर, इसमें
Yes?
सिर्फ सीमेंट सकते हैं एज अ बेंडर।
Yes, exactly. We have cement and stone chips. Because in the ratio, we have only two ingredients. Okay, this is 1:3. There can
ओके सर।
be there can be another ratio as well, no problem. And you have to then calculate materials based on the same ratio. Like if there is maybe ratio of 1:2, okay, where there can be cement, okay, and there can be actually sand, and there can be stone chips. So these three things. Then you have to just put the ratios for the same material calculation. It's the same process can be used. Okay. Let's move ahead. And next we have actually the pointing. Okay, are you guys familiar with pointing? It is the same thing as plaster, but we do not cover maybe the brick faces, maybe the headers, maybe the stretchers of the brick. Okay, so we don't cover them. We just fill the joints, and then that is just known by the pointing. And these things are very famous
ओके सर।
in the construction of the, you can say, walls of the government buildings, maybe you can say. Okay. Let me just show you the diagram. You can see it. We have the, let's say this is brick, and here the joint is just filled with the mortar. You can see that. There are a bunch of types, okay? However, these two are very common, so I have just picked them, okay, up in the same presentation, okay? One is just actually the deep stroke pointing, and then we have the flash or flush pointing. So these two are commonly used, okay, for buildings. That's why we will just cover them only. The process or maybe the analysis for the same pointing is actually the same thing as the analysis for plaster work. Now, what we do in plaster work is actually we determine the wet volume, then we determine the dry volume, because plaster is actually just the same thing as mortar. Okay. And then we, of course, we determine the cement and then the sand. We actually repeat the same process for the pointing. However, in plaster, the thickness of the plaster and the thickness of the pointing can be different. Okay, what should be the thickness for the deep stroke pointing? It should be 13 mm. And for the flush pointing, it should be 6 mm. Is that clear? Okay, so we have some message in the chat. No sound, sir. I'm just in hurry, and I will just do one more topic, and then we will end the session. Okay. So in the pointing, we have these two types. Okay, deep stroked. Okay, here I have just mentioned stroke. It is just actually deep stroked. Okay, and then the flash pointing. So you have to use 6 mm thickness for the flash and 13 mm thickness for the deep stroked. Okay. Okay, let's just have an example. You guys can see the screen, right?
Yes, sir.
Okay, here we have a flash pointing, and it is, you can say, 800 square feet. Okay, the area that is just 800 square feet. Now the cement mortar, that is actually 1:3. I think this data is just enough to determine different materials for the same pointing. Okay. Now, you have to use 800 SFT, I mean the same area for deep stroke pointing. And then you have to send me the quantity of cement and then the quantity of sand, okay? Let me just calculate these two things for the same pointing. Okay, what we have is actually we need the volume of the pointing. For that, we will just multiply the the area of the pointing with the thickness, okay? The area that is just known, which is 800 SFT, and the thickness that is also just known, okay? If you remember, we have noted it, right? And that is actually 1/4 inches, or maybe if you remember, you can see it, okay? 6 mm. So 6 mm is just the same thing as 1/4 inches, okay? For the deep strike, you have to use 1/2 inches, no problem, or you can say half inch. Okay, so now the volume must be area times the thickness. Area is known at 100. The thickness is 1/4 inches. But if you see the area that is in square feet, however, the thickness, it is just 1/4 inches. It means we have to convert inches into feet first, okay? That's why we have to divide this by 12, okay? Because 1 feet means 12 inches. Now, area times thickness, that should be 16.67 CFT. Very easy. Now, once we have the volume, it means we can easily calculate the materials. It is just the same formula, okay? Like the cement equals the quantity of the material, the ratio of the material divided by the sum of ratio times the dry volume. It means we need the dry volume, okay? Now, it is the same thing as the mortar. So in order to determine the quantity of dry volume, we have to multiply the wet volume with the factor, which is 1.27. Okay. Now, never ask me where 1.27 comes from. Okay. Because we have already covered it. So it means the dry volume is now 21.167 CFT. Very easy. Okay. And now we will be just determining the cement for the same pointing, which is 800 SFT. So the cement must be the ratio of the cement, which is 1, divided by the sum of ratio, which is actually 4, and times the dry volume, which is 21. Okay, just do some maths. We have actually 5.29 CFT. And you can even divide this by the volume of one cement bag to have 4.23 bags, okay? And the volume of one cement bag over here in Pakistan, it is actually 1.25 CFT. So by dividing that volume by 1.25, we can have 4.23 bags. And next, sand is very easy and straightforward. So sand must be the quantity of the cement, which has just been calculated. You can see that times the ratio of the sand, which is 3. Okay, you can see it is just 3. And just multiply these two, we have actually 16 CFT approximately, okay, which may be 15.8 or 9 something. That's why I have written 16 CFT approximately. So this is how we can calculate different materials for the pointing. If there is any question, I'm ending the session.
ये 1/12 ये कहाँ से आया है 800 मल्टीप्लाई ये 1/4 मल्टीप्लाई 1/12
Okay.
1/12 confused.
That's a good question. Okay. As you can see, we have 800. Okay. That is in square feet. But 1/4, that is in inches. It means we have to convert inches into feet first. Okay. That's why we divided it by by 12. Okay, if there is inches, you can say, let's say we have 6 inches, and you need to convert this into feet, you have to divide it by 12. Okay, it becomes 0.5 feet. So similarly, we're here, you can have the same process. Okay, is it clear?
No sir.
Okay,
Again.
okay. Let me have another slide, okay, so I can make you understand.
Okay sir.
Just a simple one. Okay, let's have another new slide, and then you can see the screen, right? It is just simple conversion. It means, if you remember, 1 feet is just 12 inches. Okay, it's simple. Now, in order to convert inches into feet, you have to divide the video by 12. Let's say we have 3 inches. So in feet, what should be the video? That's the reason we have to divide 3 inches by 12. And that then becomes 0.25 feet. Okay. So similarly, if we have 1/4 inches, you have to divide the same thing by 12. But we cannot write it in the same way, in the same form mathematically. So that's the reason I have put this video over there in terms of 1/12. What do you guys see now? Is it okay?
Yes, sir. Okay, sir.
Oh, okay.
Right.
Never be confused by that. Okay, I'm gonna change this thing to in simple form. Okay, let's say we have 1/4 inches. What do you mean by 1/4 inches? It means 0.25 inches, right? One
Yes,
over
sir.
four, 1/4 inches means 0.25 inches.
Yes,
Now,
sir. Right.
now you have to divide 0.25 by 12. Simple. Okay. So it is the same thing. Is it clear now?
Yes, sir.
All right. Is there any question now?
यस सर
And what is it?
सर जिस तरह 1 सैकड़ा बराबर होता है 100 क्यूबिक फीट का तो
Yes.
1 सैकड़ा कितने क्यूबिक मीटर का बराबर होता है
Very good. Very good. I'm not gonna tell you the exact video, but I'm gonna just convert it to you so you guys can even work it for. I know the video, however, but let me just convert it for you, okay? And how do you convert actually it? Okay, without just it is actually like approximately 2 point. Wait a minute, it is 2.83 cubic meter approximately. But let's just work out it. Okay, we have 100 CFT. Okay, you have to divide this by 3.281 cube because 1 meter means 3.281 feet. That's just clear, okay?
Yes, sir.
So 100 divided by 3.281 cube actually becomes 2.83 cubic meter. So 1 sacra is now the same thing is 2.83 cubic meter or just 100 CFT. Okay, guys. See you tomorrow, inshallah. Allah Hafiz.
Okay, sir. Thank you.